The last little piece of the puzzle for these graphs is something called period. A period is a distance horizontally. We talked about one full cycle of a graph. You know, it keeps going on and on forever. A period is that distance representing one cycle, not the overall distance because it goes on forever, but one cycle from where it starts and where it ends. Now remember, in a sine, of course, the graph will start at the midline, go up, down, and back up, and end at the midline. So that distance here would represent one full period. And a cosine starts at the max or min if it's reflected, and we'll come back up to the max or min if it's reflected. That distance is one full period as well. The default period for a graph, we can actually discover right here on Desmos. So if you graph y equals sine of x, and I'll do cosine of x next, if you start at the y-axis, and you can click on a few points, it won't always give you every point, but it'll give you these 5 points here, which are super important. This is the starting point, 0, 0, goes up at a maximum of 1 at pi over 2, goes back down to 0 again at pi. That's half the circle, by the way, pi. 180 degrees, right? At 3 pi over 2, that's 270 degrees, or 3/4 of the circle, you're down at -1. Remember that sine is the y value, so that's the y value on the unit circle is -1. One full completion of that circle, the y value is back at 0, that's 2 pi. So the period is this x value, 2 pi, 2 pi radians. So now I can, whether it's sine or cosine, y equals cosine of x. And let me hide this here for a second. It starts at the max, but look at where it ends. It ends at the max here, and at 2 pi is where it starts over again. Well, that's the same period as a sine. So whether it's sine or cosine, 2 pi is a little more than 6, right? 6.28. So right here, that is the cutoff. That's one full period. If I just say x equals 2 pi, so you can get the idea. X equals 0. So the distance between these two x values represents one full period of either the sine or cosine function. Now we can change that period, but I want to show you first an equation of how to do that. So the formula to change the period, now you might not see a number here other than 1, might just be x, in which case it's 1, the period is 2 pi. But if you want to change the period, you throw a number out here, you just take 2 pi and divide by the b value to change the period. Or if you want to calculate the b value, do 2 pi divided by the period, and you'll get it. Always have 2 pi on the top of that equation. 2 pi over the period is equal to the b value. 2 pi divided by the b value is equal to the period. Those are essentially the same thing, just solve for one or the other. That's one full completion around the circle representing 2 pi. So let me show what that does on a graph. If I throw, let me just do sine. If I throw a 1 in there, that b value would be 1. That period is 2 pi. If I put a 2 in there, that period actually gets narrower because 2 pi divided by 2 is pi. Pi is a smaller number than 2 pi. So that period actually gets narrower. And the higher you make that, 3, 4, 2 pi over 4, 2 pi over 5, 2 pi over 6. Think about it. When you keep dividing by a bigger number, that the overall number gets smaller. So the period gets shorter. So that horizontal distance is shorter. So you can have a really narrow graph. You could put 100 on there and basically nothing, but even 10 is really narrow. Or you could have, 1 is the default, 2 pi. You could do 1/2, right? You could widen that. So the smaller that number gets to 0, say 1/4, 1/8, that graph gets super wide. So it kind of works the opposite way. The bigger the number, the narrower the period. The smaller the number until 0, the wider the period. You're never going to go below. You're not going to have negative numbers in here. So we just deal with numbers between 0 and 1 or higher than 1. Or if it's just 1, then it's the default 2 pi. So let's do a couple examples here on Delta Math. Let's look at period. So identifying the period of a trig graph. is going to require us to look at whether it's a sine or cosine. So if you look at this problem here, and it starts at the midline, that's a sine. It goes up to the max, down to the midline again, but we're not finished yet because it has to go down to the minimum and back up. And you see at -1, once it goes back up to -1, that's when it starts over again and repeats that process. So this value on the x-axis, 4 pi over 5, that would be your period. So I would want to actually enter 4 pi divided by 5. Need the pi in there. That's in terms of radians. So one complete cycle is that distance right here. And it should be marked on the x-axis most of the time. Let's do another one. Okay, so this would be, it starts at the maximum, so it's a cosine function. So the cosine starts at the max, goes back down to the midline, down to the minimum, up to the midline, and to the maximum again. Now that max is at 4. So if you look at the x value there, that period is pi. You can type pi, or you can hit the pi button. And there's your period. Let's do a couple more. So this is again a cosine. Starts at 4, goes back down, ends at 4 again. This period is 4 pi. And let's do one more. Actually, I want to do enough where I can get some that don't have pi in them. So I'm going to keep doing them. So this is midline's at -1. It's a sine. Goes up, down, down, and back up. That period should be 5 pi, according to my graph here. And it looks like all my graphs have pi in them. So yeah, in these cases, the periods will be pi. Let me find another example that might have periods where, you know what? I'll do that in another example. So sorry for dragging on this a little bit. Just I want to utilize these formulas, but I'll do it in another video so it doesn't take up your time. But just so you know, period comes from the b value. 2 pi divided by the b value will get you the period, or 2 pi divided by the period gets you the b value. And that'll be right here in the parentheses right next to x. All right. Happy mathing. Thank you for watching.